So here we are, a room full of human beings, about to spend 40 odd minutes contemplating our evolution. It doesn't happen very often, and I don't think it happens with any other species on the planet, and as far as we know, no other species in the universe. And it's quite an amazing thing when you think about what we're about to do here as individuals contemplating our own evolution. I think it's one of the most interesting unresolved mysteries of science, and well worth our consideration. At the centre of this mystery there's a question, and the question revolves around a very surprising fact the first time you hear it, and that is that the chimpanzee, our closest relative in the animal world, is most closely related to us and not the gorilla. And that really means that if you look at our evolution from a sort of a evolutionary biology standpoint, it begs the question, what exactly happened to our ancestors that was so remarkably different from what happened to the ancestors of the gorillas and the chimpanzees? And normally in biology, when you have two closely related species that differ in some way, for instance the brown bear and the polar bear, one looks at the differences between the two species and one infers some sort of evolutionary scenario that might explain it. So that's what I propose to start with. Let's think about the differences between humans and chimpanzees and just list them all out. There's about 5 or 6 big ones, and I'm going to just quickly list them. The first one, I think, is pretty obvious, and it's what I'm doing right now. I'm talking to you. I don't think many chimpanzees could do this, but chimpanzees are very smart, and they can learn symbolic language, like this character Kanzi learned to communicate using this symbolic language to a very high degree. But chimpanzees, as far as I'm aware, have never been known to utter a sentence, or mainly only a few words, if that. So that's one big difference. Another one is bipedalism, and that's going to be the subject of this talk, so I won't refer to that anymore now. There's a trio of things that have happened in human evolution that we all have heard about. The encephalization, the evolution of our large brains, has clearly happened over the course of human evolution. And sort of related to that is the diet. So we've had to have started to eat much more energy-rich types of food to fuel this brain growth, and our dentition has bizarrely kind of gone in the opposite direction. We've lost the power of strong mastication, our teeth have got kind of reduced. And so this kind of implies that something to do with the diet, maybe using stone tools to cut food and rather than chewing it, and then maybe later on cooking to make food more easy to eat. There's a fourth one that I want to add to this list, and it's probably on this list the most controversial, and that is body hair. Now, I don't know when this slide came up. I would imagine most people would sort of look at that a little bit oddly and think, well, that's a bit strange. And it's because, of course, it's usually the other way around. It's the human that has little body hair and the chimpanzee that has relatively large amounts of body hair. Of course, as we've seen, there are exceptions, but of the 7 billion people on the planet, I think certainly half of the people and the younger people have far less body hair than the typical chimpanzee. This is surprisingly a controversial subject. I don't quite understand why. But when I first got interested in human evolution, like when Charles was describing, I bought this book, the Cambridge Encyclopedia of Human Evolution. It's quite an impressive tome, 500 pages, written by 74 eminent authorities of human evolution. You've probably heard of many of them. But he didn't even mention body hair once. Not once in the whole book. And I have to say, in our department here, we sort of follow that line, and we still teach students, despite my efforts over the years, that if you compare chimpanzees, gorillas and humans, then gibbons are the outliers because they have dense body hair compared to the great apes. Now, putting allometry to one side and the size of the individual, there's no doubt that we do have very dense follicles, and we do have a lot of hair, but it's the kind of hair is vellus hair. It's very sort of small and almost indistinguishable. And I searched the literature and found a paper that described that the place on your body where you have most dense follicles is actually on your forehead. Now, I don't know if you can see any hairs there, but I don't think it's that obvious. Does anyone recognise this character, by the way?
You actually tutored me by it, was it Oxford? It's Desmond Morris.
Desmond Morris. Desmond Morris, of course, nice link, The Naked Ape, the author of The Naked Ape. So Desmond Morris wrote this book basically on the lines that humans were quite unusual. And it's not just the hair. Another thing about humans that's quite odd is we're relatively fat, particularly infants. In the last trimester, infants put on a lot of weight compared to chimpanzees and other primates. So I'd sort of classify those as skin differences. And then finally, we've got sort of differences in respiratory system that are quite peculiar. We all have this kind of strange nose with inferiorly orientated nostrils, but lack the sort of olfaction that chimpanzees have even. And probably most remarkable of all, we have a descended larynx. The chimpanzee apparently is able to drink and breathe through the nose at the same time, as is a human infant on the breast, but we lose this ability pretty quickly. I went to see a fantastic talk by Jeff Lakeman. If you ever get the chance to hear Jeff talk, you should take it. He's a really funny, brilliant guy. Can anyone do a New York accent? Because I can't. And I would like to read this in a New York accent because that's what he said. For the first time in evolution, always, 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 the airway and the foodway must cross in the supralaryngeal space. That's a really remarkable thing when you consider that every time you swallow, you're effectively risking choking to death. Very few mammals have that as their situation. So these are just, I think, 5 of the big ones that we could sort of describe our differences between humans and chimpanzees. Now, how do we try and explain those differences? It's very simplistic, but I think it's fair to say that the model of human evolution that is most popular and everyone has sort of absorbed subliminally or been taught it explicitly is what might be called the savanna theory. And basically it's that climate change in Africa caused the trees to give way to open plains, and our ancestors were therefore forced down from the trees to adopt a new niche on the savanna. And there's a lot of good evidence for it. I'm not saying that there isn't. And it's a very popular model. All the textbooks basically teach this idea. So if we were to look at these sort of traits, speech is seen as some sort of an evolution for collaboration while hunting, perhaps. Upright efficiency of walking and endurance running is argued to be the explanation for bipedalism. Eating meat, cutting meat using stone tools is the sort of the food thing. Sweat cooling. While you're running over the plains doing endurance running, you sweat, and so the loss of body hair is probably explained in that way, and infant adiposity by keeping warm at night and helping the brain to grow. And the nose and larynx have somewhat similar sort of sensible explanations. But the savanna idea is not the only one. And there is an idea that Charles alluded to earlier, and I think it's worth some thought. It's called the aquatic ape theory, and it was originally sort of conceived by Alistair Hardy, who was a marine biologist, and he read a book on called The Man's Place Amongst the Mammals by Wood Jones. And he was talking about how odd it is that when you dissect a human, the fat sticks to the skin, whereas when you dissect a mammal like a rabbit, fat sticks to the viscera. And Hardy had dissected lots of marine mammals and had the eureka moment that he thought that maybe we had a more aquatic past. The idea was largely ignored, and then this dear old little Welsh lady, Elaine Morgan, took it up and wrote several books on it. Now, the aquatic explanations for these things are not surprisingly to do with water. Voluntary breath control while swimming would help you to speak. Wading through water would help you to encourage bipedalism. A diet rich in iodine and omega-3 fatty acids would help the brain to grow. Drag reduction, buoyancy and thermoregulation in water would explain sweat pooling and the nakedness, and a HUD for swimming, and the larynx, who knows, maybe gulping air or underwater vocalization. Now, I don't know about you, but when you look at those two lists there, I don't look at one of those lists and think how ridiculous and how brilliant the other side is. I look at those two lists and think, well, they seem to both have good points. And I don't think that either of them are great or either of them are terrible. And there's one more I want to add to that list, and that's our ability to swim. This photo was taken just off Cottesloe from an aerial from a plane, the annual swim to Rottnest, and humans are pretty good at swimming. Without any technology or much learning, you all know people that are pretty good at swimming and diving. And this was Alistair Hardy's first and foremost difference between humans and chimps. And it always strikes me that, you know, why couldn't this be due to natural selection? If you compared a pig and a monkey and said which one's better at climbing trees, no one would have a problem to say it's the monkey. And no one would have a problem to say it's because of natural selection. And I would challenge you to pick any two animals in the world and any of the substrates on land, moving through trees, flying through air or swimming in water, and to offer an example where natural selection wouldn't be the explanation for that difference. But it seems when it comes to water, we have to invoke other things. It's because we're smart. We can do all sorts of things. We can play the trombone, etc. Now, Alistair Hardy basically came up with all these ideas in 1960. His paper, a very short paper, ended in a very modest way. He basically said, it's only an idea. I'm only sort of floating this idea to see if anyone might be interested. And it's really disappointing to me that no one really took it up for several years until Desmond Morris mentioned it in his Naked Ape, and then Elaine Morgan picked up on that book. So if you look at the response, it's been very little. In fact, the majority of neutral papers written on this subject have been quite open and supportive. I've discounted from this list all proponents. These are neutral papers. You can see there, for instance, Chris Stringer, Philip Tobias, Colin Groves, people like that. They've all written on this subject in an open way. In the literature, the papers that are rejecting this idea are in a very extreme minority. There are only 4 that I know of, and they're not very good if you read them. So it begs the question, really, shouldn't we be taking this more seriously?
I see Elaine Morgan, through a series of superbly written books, presenting a challenge to the scientists to take an interest in this thing, to look at the evidence dispassionately, not to avert your gaze as though it was something that you hadn't ought to hear about or hadn't ought to see. And those who are honest with themselves are going to dispassionately examine the evidence. We've got to, if we're going to be true to our calling as scientists.
So Philip Tobias is one of the few people who actually was a proponent of the savannah theory for many years, and then came down and said that he got it wrong. And he was reconsidering it, and in his later years he had a number of students under him that were studying these sort of ideas. So this is sort of where I sort of came into this thing. I was looking at the savannah theory, and I was looking at the so-called aquatic theory, and trying to think, well, can't they both work together in some way? Do they have to be opposed? Does there have to be a big polarity of debate here? So inspired by Alistair Hardy, Elaine Morgan and Philip Tobias, I decided to try and do some of the science that hadn't been done on this subject. And of all the list of things that we looked at earlier, I chose bipedalism. That's my dad, the one on the right. He was in a wheelchair for the last 37 years of his life, so I don't know if that sort of subliminally made me interested in bipedalism. But that's the one I chose to get interested in. So this was my PhD that I finally handed in a few months ago, thanks to Charles and my dear wife for gentle nagging for many years. So basically, as all PhD theses do, it started off with a comprehensive lit review. Basically, I went through all of the literature I could find on all the different models of bipedalism. Now, you could argue that there are different categories. There are some of these models overlap. Some of them are kind of maybe should be split further down. But there are ideas here, if you just scan your eye over that list, that you probably recognise. Now, one thing that's missing in the literature, I think, is any attempt to evaluate these models. You always, whenever you read a textbook on bipedalism, the author seems to have a few favourites that they mention, but it's opaque as to why they've made that decision. So I thought, well, I'm going to try to come up with a marking rubric. It's something we use every day in academia. You know, we've all sort of either done essays or had essays marked or marked essays, and the procedure is to come up with some sort of an ideal set of criteria that you think would be a good model, a good essay, and then you mark it completely. So it seems bizarre that the currency of academia is marking and a marking rubric, but no one's applied it to this. So I came up with 4 main categories of criteria to evaluate these models. First one there, survival value. So the idea is that the model, that the bipedalism should provide survival value for these apes or whatever ancestor of humans were doing this bipedalism. And it should improve sexual selection, or at least not reduce it. Not teleological, meaning that it shouldn't be something that obviously benefits us humans, and we just, looking at it from our point of view, it should have been a benefit all the way along. So I'll just whiz through these. Ecological things to do with food improvement, evading predators, and it should have good analogues in extant apes. Paleontological, so in other words, it should meet the fossil record. And a category I call epistemological. So it should basically have other things that it explains other than just bipedalism, and it should be complementary to other models. I think that there are so many ideas that have been published over so many years, it's unlikely that one of these ideas is going to actually be absolutely right, rendering all of the others absolutely wrong. So I think a compatibility of the ideas is quite important. So I basically went through all of these criteria, and I evaluated all the models that I could read. And I've been very open about this. That URL there, it will take you to a website where you can look at my evaluations and check them and criticise them, and you can put in your own evaluations if you like, and you can send them to me and we can discuss it. But basically this is an open attempt to evaluate all the different ideas of bipedal origins. And I have to say that I did this as fairly and as objectively as I could, and the wading models always come out top. Now you could criticise that and accuse me of bias. These are some of the marks. The ones in claret are just a very simple marking rubric here, good, fair or poor. And you can see that I've given the same mark for survival benefit for the wading models as several other models. So I've tried to be fair. In fact, probably I think I've been too fair. So let's have a look at these. I'm going to whiz through some of these criteria. First of all, survival value. Now, there is no model of bipedalism that is as clear-cut as this. If you are quadrupedal, you die. Now, there is no model that can say that. And it's almost trivial to say it, but it's undoubtedly true. Another one, I think, that sort of backs that up and is very powerful is that it provides analogous behaviour in extant apes. This is something Kevin Hunt talked about in his postural feeding study. He basically did a study of extant apes in the wild and found that the place where they were bipedal most often was while feeding. But of course, that was tend to be in trees, holding a branch with one hand while picking food in another hand. That's not really bipedal locomotion. So what about this? Well, there's no doubt that extant apes are largely quadrupedal when they're walking on dry land, and without exception, they are bipedal when they're in water. Now, I've got some beautiful footage, and I've got to thank Stephanie Young for this, because she put me onto this clip. I hope it's going to load quite. I'll show a few seconds of it. It really is beautiful. I won't enlarge it, it takes a few seconds. There's an orangutan in Borneo, and it's wading bipedal. Now, there is no other model of bipedal origins that can say, put a group of chimpanzees or gorillas or orangutans in scenario X, and they will all move bipedally without the use of their upper limbs forever. Now, that has got to be the best piece of evidence possibly imaginable on bipedal origins, and yet it's been ignored for 60 years. So, What about the fossil record? Clearly, if there's anything in this, we'd expect to see good fossil evidence for it, right? Well, if we look at let's pick just a couple of examples. Lucy, the famous one, Australopithecus afarensis. This image was taken from Don Johansson's book on the subject, and the Hadar habitat where Lucy was found was literally a wetland for about 1 million years. Recently, there's been some paper published where Lucy apparently fell out of a tree and maybe died falling out of a tree, and so there's no doubt that there was some dry land there as well. But this is definitely the habitat of Hadar. Going back earlier, Sahelanthropus charensis, one of the earliest pieces of fossil evidence for bipedalism. This individual was found in the middle of Paleo Lake Chad alongside strange creatures which are ancestors of the hippopotamus. So this is, again, very closely associated with wet habitats. And here's a list from my thesis of paleo habitats of early hominids. And the only exception really is Laetoli, of all the different hominid sites which have been associated with bipedal origins. Now, another thing I want to pick out here is the complementary nature of the wading idea. And I think it is. I think it's very complementary to almost all the other ideas. For instance, carrying. There is no better place imaginable than carrying an infant when you're in chest-deep water. Peter Wheeler's thermoregulation model. This is the idea that humans started walking on the savannah in the midday sun to avoid too much solar radiation on their backs. And the idea that placing the chest high up is going to expose it to more cool breezes, which will keep it cooler. There's a better way of keeping cool, though, isn't there, surely? What about the energy efficiency model? Energy efficiency is clearly the most difficult one to be compatible with the wading idea, because wading up to your armpits does cost a lot of energy. So this is the one that I really want to spend some time at. And some of you may recognise the character in that in the pool there down in Human Movement. That's Warren, who was in this department doing a PhD alongside me for many years. So we basically did some wading experiments.